Okay, so we're going to learn about geometric series here. I had a little typo, so I changed that to topic 4. So, a geometric series is when you take the terms of a geometric sequence and add them up. All right, and so we'll just jump right into the formula for a geometric series. And there are two types of geometric series. There are what is called a finite geometric series or an infinite geometric series. And so finite means a set number. So like, oh, I want you to add up the first 12 terms or the first 80 terms or whatever of this sequence. Where infinite, we'll see in a minute, is where you are adding all the terms forever and ever and ever. And so there's only a special type of one for infinite that you can do, which we'll talk about when we get there. All right, so here we go. Let's see, the formula. The sum of n things is going to be a big fraction. You take your first term, then you multiply that by 1 minus r to the n over 1 minus r. All right, so remember r is your common ratio, a1 is your first term, and n is the number of things. All right, so let's do it here. Find the sum of the first 8 terms of a geometric series with a1 is 6 and r is 1/3. So I like to see what I'm doing here and also see what the pattern's going to be. So if I start this off, 6 multiplied by 3 is 18, multiplied by 3 is 54. All right, so 8 terms, I could probably literally just find the rest of the terms and add them up, but we're here to use the formula. But I do see that they're all positive, and I'm going to go ahead and know that it's going to be kind of a large positive number. All right, so I'm doing the sum of 8 things. Big fraction, first thing is 6. I have 1 minus, my r value is 3. I'm taking that to the 8th power. And then the bottom, 1 minus 3. So the only thing I can really do myself here, 1 minus 3 is negative 2. But let's go ahead and put the calculator. So make yourself a fraction. I have 6, 1 minus 3 to the 8th. And 1 minus 3 is negative 2. All right. And there it is, 19,680. So just what I was expecting. All right, so just to make things a little bit more difficult in this next one, I'm going to go ahead and put a negative sign on this 1/2 just to show you some stuff. All right, so find the sum of the first 20 terms over the geometric series, with the first term is 12 and the common ratio is negative 1/2. So let's write it first for the first few terms. So I would have 12 multiplied by negative 1/2 is negative 6. Then multiplied by negative 1/2 would be 3. Then negative 1.5, and so on. So the numbers are alternating. So let's do that one. So I'm doing the sum of 20 things. So this is where you have to be careful. The first term is 12. I have 1 minus. Now my r value is negative. So you want to protect that. And it's negative 1/2, so I'm going to put negative 0.5. So if you can, it's easier to type a decimal in your calculator. If you can't, you just make another fraction there. And then we want to the 20th over 1 minus, and I have a negative 0.5. So I don't really, the bottom part, I hope you notice that turns into 1 plus 0.5, right? So that's 1.5. So that's what I'll put in my calculator, but I can't really do that on the top because that 20, this 20th power is going to be going on that negative 0.5. So also something else to mention, this changes to a positive. This one does not. This 20th power is going to turn that negative positive, and so I really do have 1 minus whatever this turns out to be. All right, so 12.5 and 20. All right, let's see what we got. So I got 12, 1 minus, parentheses, negative 0.5 to the 20th. All right, and on the bottom, 1 minus negative 0.5 is 1.5. All right, I think I've done it correctly. There's my answer. So sometimes if you can make it a fraction, so math and then fraction, okay, it did make a fraction. Oh, so it is better to write that fraction down, but oh my gosh, I'm not going to remember it. 104.8575. All right, over 131,072. All right, but what does that mean to everyone? Well, you can also say approximately, that's those little squiggly equal bars, and say, oh, it's approximately 8, basically. So about 8 if you had to really say. Okay. So, obviously, like, this is better, but if you wanted to say, approximately 8 or 7.999 or whatever, so you could say that too. All right. So, with these, I'm just going to show you how you can put them in the calculator. Again, you could get all the information you need from here. There is your first term. There is your R value. And from 1 to 6, that means the number of things is 6 things. So you could, again, put them in this formula. But 5 and 2 from 1 to 6. So if you're putting this in the calculator, math button and your summation notation. So we're going to put x equals 1 to 6. Now, these parentheses are the calculator's parentheses. They're not your parentheses. So you cannot use them. You see, I can't get in front of the parentheses if I move to the left. So you have to put everything of your problem inside these parentheses. So when we're going to go and type this 5 times 2 to the n minus 1, I have to type that all in here. 5, I have to make my own parentheses, 2 parentheses, power, and then x minus 1. So everything fits inside those parentheses that were given to you. Okay, 315. All right, so now we get to this last thing, and this is an infinite geometric series. So let me tell you the formula first. So the sum for an infinite series is a1 over 1 minus r. This only works in special cases where r is between -1 and 1. Or in other words, r, the absolute value of r, is less than 1. So that means that this only works for r values between -1 and 1. And so the reason this is true is this. So let's pick one. Let's pick like a half or something. All right, so let's say we start off with, 80. And then we go down and we do half is 40, and half of that's 20, and half of that's 10, and then 5, and 2.5, and half of 2.5 is 1.25, and so on. So what's going to happen here is the numbers are going to get super small. I can keep taking a half forever and ever and ever. But what happens to my problem is this. I'm starting off large, then I'm half. It reminds you of a decreasing, like an exponential function. It never gets negative, it never gets to 0, but all these numbers, all these answers out here get so small, they basically kind of turn like unimportant. So what this formula does for us is it basically like sums up everything, and these numbers get so close to 0, it converges to 0, all right? So if your R value is between -1 and 1, that's what's going to happen to your problem. Now, if your R value is negative, then what's going to happen is you're going to get alternating answers, positive, negative, positive, negative, positive, negative. But you can see they still both kind of come towards 0. It just still gets smaller and smaller and smaller, and if it's negative, larger and larger and larger, but they approach 0. And so patterns that do this, you can do their sum to infinity, because basically the numbers towards the end of the pattern don't really affect your final answer that much. So anyway, if you want to do the sum to infinity, you need 2 items. You need the first term and you need your R value. Okay, well, here we go. And look right here, I have this infinity, so I know to do this formula. So my sum to infinity, A1 is sitting right here, so 4, and R is 0.6. So it's taking a pattern. 0.6 is small enough, right? It's less than 1, or it's between -1 and 1, and it's multiplying by 0.6. So let's do that a little bit. 4 times 0.6. So 4 times 0.6. And let's multiply by then multiply by 0.6, and there's your answer. I keep doing it. And see how that number is getting smaller and smaller and smaller, and if I keep doing it, it just gets littler and it affects the final answer less and less and less. So that's why you can go ahead and do this sum to infinity. So I need 4 over 1 minus 0.6. So that's 4 over 0.4. So I'm just going to, so I don't have to go back to my calculator, let's do a little trick here. So I got 4, and remember 0.4 is 4/10. So I'm going to write it as a fraction. Oops. All right. So that's 4 times 10 over 4. So the 4's cancel, and I get 10, rather than pulling out my calculator. All right, so this series right here, let's see what's going on. 16, -8, 4, -2. So I can take any of these numbers and divide them to find my R value. I mean, I know my first term is 16, that's easy, but I need my R value. So let's just take these two. Let's take 1 and divide it by -2. So there's my R value. So my sum to infinity is 16 over 1 minus -1/2. So that would be 16 over 1 plus 1/2. So that's 1.5 or 3/2. So I get 16 times 2/3. So I get 32 over 3. And there you have it. And that is it. Bye-bye.